Let's look at a question on which planet day is longer than a year. If you look at planetary data, it shows two interesting cases. Mercury with a rotation period of about 59 days and revolution period of about 88 days. Whereas Venus, rotation period of 243 days and revolution period about 225 days. You can clearly see that Venus rotation period is larger than revolution period, and therefore one may think that Venus has a day longer than a year. But no, that's not the case. What is a year? It is duration needed by a planet to move around the Sun. If the rotation axis of the planet is tilted, like that of Earth, there will be seasons observed during its passage around the Sun. And it will be easy then to observe the change of year by observing season cycle. So between, for example, two monsoons in India, it will be called a year, or it could be two autumns in temperate countries, where it will be called a year, or two springs, it will be called a year. What is a day? One may think that it is duration needed by the planet to rotate about its axis or spin about its axis, but that's not correct. That's wrong. Day, for all civilian purposes, is defined as duration between two noons, or nowadays between two midnights. What is a noon? When the sun comes almost overhead, or what we call meridian, it is called noon. So when sun crosses from eastern sky to the western sky, that's a noon. And it's the boundary between east and west is meridian. Okay, it is line joining north and south through the exact overhead point, or called zenith. So when sun crosses this meridian, it is noon. Solar day is duration between two consecutive passages of the sun over meridian. We use this day for all civilian purposes. And this day is divided into, say, 24 parts, each part we call an hour, and so on. What is rotation period then? Rotation period or spinning period is called sidereal day. It is with respect to stars. Rotation period of planet gives duration between two consecutive rising of any star, which is called sidereal day. Now, sun is also a star, but we are so close to sun, we revolve around the sun, and therefore the relative motion of the sun with respect to other stars is quite large. So that is going to therefore cause the difference between the two definitions of a day, sidereal day and solar day. Now let's look at that. So say sun is over here, and this is the orbit of the earth, and the earth is at this point. You are standing on the earth, and right now overhead the sun is observed, or at least you are on such a longitude, you are on that particular longitude where everywhere the sun will be observed on the meridian line. That's called noon. Now after one complete spin, as earth moves along its orbit, and it also spins in the same direction, after one complete spin, the earth will reach here. This is one sidereal day. So you can see that your orientation is parallel to your earlier orientation. But this is not exactly towards the sun. And for that, you will have to further rotate, okay, in anti-clockwise direction in the same sense. And during that time, earth will slightly go ahead. And this position will be called a solar day. Now this is an exaggerated figure for earth. Okay, the duration for earth, the sidereal day is 23 hours 56 minutes 4 seconds, whereas solar day is 24 hours. So additional 4 minutes earth will have to travel so that we get another noon. Now formula connecting the solar and sidereal day. So what is that formula? For any random planet you want to do this calculation, what is the formula? So the formula is based on the relative motion. So the 1 by solar day is 1 by year minus 1 by sidereal day. And 1 by solar day, in our case, solar day is 1 day, and there is a negative sign indicating that as sitting here on the earth, the daily motion of the sun is from east to west, whereas in astronomy, we consider all motions going from west to east as positive. So, for example, the revolution of the earth around the sun is from west to east. The rotation of the earth about its own axis is west to east, and we consider all those motions positive, and with that convention This becomes a negative motion as sun moves from east to west in our sky. Year is 365.25633 days, and sidereal day is what we are interested in finding out. So when you put this in formula, 1 by sidereal day is 1 by 365.25633 plus 1 upon 1 by d, and that gives you a fractional day which is slightly smaller than 1 day, and when you convert that into hours, minutes and seconds, what you get is 23 hours 56 minutes 4 seconds. That is sidereal day. Now how about applying this formula to Venus and other planets? So if you apply it to Venus, what we get is this same formula. Now we substitute the numbers. The year is 224.7 days. We don't know how big is solar day, but we know its rotation period or the spin period, which is minus 243.0 d. Negative sign again indicating that Venus spins in an opposite direction to itself. And when you put these numbers together, what we get is 1 by solar day is 1 by 116.7 days, indicating that solar day is 116.7 days, which is smaller than a year. The year is 25 days approximately, and this is quite smaller than that. So solar day on Venus is smaller than its year. Okay, it was misleading to look at the period of rotation, period of revolution, comparison, and seeing this. What about Mercury? So in case of Mercury, 1 by solar day is 1 by 88 minus 1 by 58 or 59 days, and we get something like 175.94 days or 176 days. The solar day therefore is about 176 days. Solar day on a Mercury is greater than a year. Day is actually twice the year. So numbers could be misleading. Day on Mercury is actually longer than a year, though its spin period is smaller than its